Hi everyone, my name is Patrick Akil, and if you're interested in how software engineering is evolving, this episode is for you. Joining me today is Borislav Nikolov, previously principal engineer over at Booking and now hands-on CTO over at Recce. He solved many complex, large-scale computing problems, and I love picking his brain. What makes a software engineer great nowadays, especially how this role is evolving. So enjoy. I've been in teams where certain people of the team like executing, like for example, delivering value to customers, and other ones like solving technical problems. And then all of a sudden, those people address more technical problems that we have because they like solving it. And there's like this disconnect because from a business side, they want functional requirements or at least functionality for users that drive value. And then the people that love solving technical problems want to solve those technical problems. But not every technical problem needs to be solved. It really depends on kind of this business context. And I feel like not everyone has the scale of, let's say, a booking organization.
No.
So then there's this itch probably that never gets scratched.
Yeah.
And that's a hard one.
Yeah. I think one thing you can obviously do is just go and see what people do. Like just go to conferences and just get out there and just see and meet people. Right? Another one is to just work with constraints. If you, another way to fake it, basically is just, try to make a good program on just the Commodore 64 or like just Z80 or like something with like few kilobytes of RAM and super slow disk, and just this also makes it interesting.
Okay,
it's constraints basically.
Yeah.
If you say I only have, or like try to do something, I can only do that in 10 lines of code. So this has to be 10 lines of code. That's what I do sometimes. Just when I have to do something, or just look at each word, each keyword that you write. It's like, how can I write this what is the cleanest for me? I don't think there's like a generic clean code thing, but for you as an individual, what are you going to be like just proud of if you just write this like 10 lines? And then you can just kind of like get away from the whole thing, the octopus that is like happening and because in enterprise, everything is connected to everything. It's just a huge, nobody knows if a code is used, you know? Let's say designers have this problem with CSS and you can't delete anything because you don't know if it's used.
Yeah.
And so how you just keep like piling, right? But you can just, even in that situation where it's just a pile of like disappointment, you still can find like islands that you still can express yourself.
I see what you mean.
Yeah. So just don't be like, it's just shit and I have to do it and I just have to. You can still like try to find these moments of creativity, and nobody's gonna value it because it's not gonna bring more money, but it's gonna bring value to you.
Yeah.
So I think that's. People should do that more, I think.
I like that a lot. Like it's experimenting with things that kind of you do day in and day out that brings you joy.
Yeah. Just try it. It's nothing bad is going to happen. Maybe somebody on the code review is not going to understand it.
Exactly.
And then you'll be like, that's fine. It's okay.
Yeah.
It's okay.
Yeah. I mean, it's hard because I've seen people really get attached to the code they write, right? And specifically when you figure out something that you really like and that it works, when it comes to a code review and people critique it, that's where a lot of discussions happen. I
think they have to realize it's not personal. It's not for you. It's just not personal.
Yeah.
Look, I am very unfortunate that a lot of the code that I've written is still running. I just wish it wasn't. I think.
Really?
Yeah, I think.
Why is that?
It's not good code. But I'm the happiest when I delete my code.
Okay.
I'm just so happy. Especially somebody else comes in and it's like, I found another way to solve this. I'm like, that's amazing. I can learn a new way to solve this, first of all.
Yeah.
And always, when you write something, you have to give it like the desire. First of all, you have to make it deletable is the most important thing for basically technical debt.
Okay.
If you can make code deletable easily without like as few tentacles as possible, it's easier for the company to grow. And so that's why I'm really happy when my code is deleted. Also, because then you don't have to be on call for it. But once code is written, it's done. If you've looked at a code that you've written like 6 months ago, and if you don't find that like disappointing, then you just haven't grown. So you should be like really happy when your code is outgrown, so that by you or by somebody else, so that you can just learn.
Interesting. I've never heard this approach of writing code that would be easy to delete, let's say. But I do like the most experience I have is with Go as a programming language. And there the language is set up to be simplistic. And also with regards to interfaces, separation of concerns, I think I would be able to delete things easily, to be honest.
Go is particularly, I think Go is, as a language is quite, I don't know, boring, I would say.
I love it.
I mainly, I also code mainly in Go at the moment. You don't think, you just, code gets written, like if error. It's okay. But there's no cognitive load when you write Go.
Yeah.
When you write, like, I don't know, anything actually, if you write Lisp, it's like, okay,
what's going on here?
There is a thing called, the Ford people say, design at the keyboard.
Okay.
So which means that as you're typing the code, you're like making it. And that's what happens in Go. Just design at the keyboard. You don't actually think about it. You can just write it out.
Yeah.
While in a lot of other languages, you have to, like if you write a Ford program, it's impossible for you to write it like that.
Okay.
You have to make it on pen and paper and just see what am I actually going to do with components and what I'm going to write. Lisp is similar as well. So anything that's designed at the keyboard, there's no cognitive load. That's the point of Go. You can just write the thing, and it's like simple, because if it's simple to write, simple to read.
Exactly.
So I think it's okay. It's just not very expressive, but it's a really productive language.
You think it's good for like longevity? Because that's usually the argument that I use. If it is simple to write, it's simple to read, it can be maintained for a longer time.
I don't. When the first version of Kubernetes, a bunch of Java people, I think, wrote it. So if you look at the code, you can write Go in a kind of like a Java way.
Yeah.
You can write Go in kind of like a C way. But you can't go it's quite a centrist a little bit. So for longevity, and what helps a lot with Go actually for longevity is tooling. Because of the way you can parse it and the way exceptions do not bubble. First of all, panics are not idiomatic in Go. So actually, I think that's what helps for longevity, is because a tool can reason through the tree and be able to find, for example, dead code, unused code, etc., etc. That is much, much harder when you, for example, let's say in Java, let's say you use like Lombok or something that just injects it's invisible code. And then you don't actually know what's happening, and nobody knows what's happening. That's just not the case in Go. So I think that's actually what helps with longevity. It's not the syntax, it's just particularly the no exception, I think. It's also, that's why I think Go is a great language for like language models to write and read, because they don't, transformers, they are shallow. So I don't think they can, I
was going to say.
They're shallow as in shallow circuit, they can approximate shallow circuits, and they can't recurse. But so therefore, if you have exceptions, like something is like bubble up all the way down from the stack, they can't think about it properly at the moment, right? That's where we are now. So in Go, that's not the case. So it's just very linear. You know how errors propagate.
Yeah.
So
but you have to handle them.
Yes. Yeah. It's just not idiomatic to panic. Even, of course, you can panic.
People try.
There are some. You can see that some people like try to say, "Oh, I just want to throw an exception. I want to catch it all this, so I'm just going to defer recover here." But that doesn't pass the code.
It's not advised. No.
Even interfaces are actually not idiomatic in Go. If you people, they are, of course, but they're more like readers and etc. But not. Or let me just add like an abstraction between those two. Let me split that.
Not without a point.
Yeah, exactly. Which is not the case in like Java, for example.
Yeah.
So and I think that's what makes it maintainable, because you don't have extra layers between what's happening and what's using the thing that this bridge. So therefore, it's really easy for you to read and go down and up. I think it's really easy to onboard in a Go project because of that.
Yeah.
Because just you just read it. You don't have to guess. You don't have second guess what is actually going to happen when this function is called. You can just read through it, which is not the case in most other languages.
Exactly. When it comes to like languages, I see them as tools. For me, the most comfortable one is Go, and it's just my first, let's say, production experience was that language. I've since done Kotlin, I've done a bit of C#, but Go is like the one I keep going back to.
Yeah.
I feel most effective in executing. And that is one aspect, I would say, of what makes me as a developer. But I'm curious to hear what you think makes like a really good software engineer, developer, however you want to label it.
I think, well, first of all, I think well-roundedness is what makes it. First of all, understanding how the computers work. What does it mean? What is an address? What is actually an address? And what is actually an if? And how does it actually work electrically?
But why does that matter? Because I don't understand that, I think, for example.
Because all the languages that we've built, besides the one that we've discovered, like Lisp and Lambda Calculus, all the man-made languages are leaky abstractions on top of these machines.
Okay.
So even though we build all these like things, they leak. Like, for example, how cache lines work and what does it mean to read and write from SRAM. And it's not just a made up, it's not just like we try to hide it, but we can't. The other thing is, I think, of course, if you're like, if you understand networking, how does IP over IP work and how does the cloud networking works?
Yeah.
Like VLANs and IP over IP, etc. And how does then to understand design, to understand project management, to understand now data science. I won't even call it this. I just understand the transformer. That's, I think this is what actually I think makes a good developer, because there is no, like, the code itself is useless without these other things. And not understanding your customer is also a problem. Not being empathetic with your customer, not being it's just everything is just one. There is no. I don't split developers in backend and frontend. Makes no sense.
Okay.
For me, it's just you either write the program or not. It doesn't really matter.
Well, why does that split not make sense? Like, are you a fan of the full stack roles that people have?
No, I just think just code is code. Okay. If you can, the complexity, I think front is much more complicated than backend. Depends on the backend, of course. If you do like these large scale distributed systems and you have this, I think people misunderstand how difficult it is to write a byte on disk to have guarantees on that. And then on the front end, you have like so many problems. So the way you think is actually what matters. It doesn't really matter if you can get a little bit more experience on this or on this. Yeah. But the concept of like transferring information and losing like order of things, systems, and even and the guarantees and what can fail, what cannot fail, etc. is the same.
Do you think these abstraction layers, and I'm specifically thinking of what we've done now on the front end, are making things more complex? Because we have,
I think so,
frameworks, and then we have cloud providers that like operate on specifically those frameworks, and you have so many flavors.
Honestly, when React went to hooks, like that was we have to go back now.
Really?
Yeah, I think.
I like it from a usage perspective, but then it's.
I mean, like a few days ago, I had to like chase this bug. This like use effect with like, I don't know, it was like had like 20 parameters.
Oh yeah.
And I was like, this is just a rendering. And I was like, this is just
what a mess.
How did you end? I was like, how did you end up here? Just ridiculous. The size of it, the size of everything. I think it's incredibly complicated. And the sad part is it's still Excel. And just Excel and validation, like we still cannot properly do front-end validation. I think the whole tangent is just wrong.
Okay.
I mean, I don't know how many times you've done, I mean, in the years, like just a form, and you have to just, okay, if this is if this is wrong, the email is wrong, or like that is wrong, etc. You just have to have feedback, etc. And now, but what if the user exists. So now you have to I have to send that here, and then you do this. There are 1,000 ways to actually, because effectively what you want to do is you have to propagate some state from the database, right, into the face of the user.
Exactly.
And we are still doing it like we were doing it in the 96.
Okay.
It's really
nothing changed.
Nothing changed.
Really?
No change. I think so. Yeah. I think there are literally no changes, and we're just going in circles.
Does it have to change? Because the fact that it hasn't changed for 30 years is a bit ridiculous. But then again, if that kind of fulfills the need that we have, then maybe it doesn't need to change.
Let me give you an example. I think that the very best interface the best ideas we have had in the last 60 years maybe is the Unix pipe.
Okay.
So the Unix pipe is no program knows how it's going to be used, and no programmer knows how their program is going to be used. Okay? But when you write something, let's say cat or tac or whatever, right? You don't know. We don't know what it's going to do, how the user is going to actually use this. And in everything else that we've built in the front-end world and the front-end back-end interactions and this, a whole team has to know how a user is going to use this thing, you see? And there is no such thing as reusable code. That just doesn't exist.
Okay.
You have to if you want to do the same thing, you can just copy some things, but it's not a thing that the user can use on another website. You know what I mean?
It works in the same ecosystem, but otherwise not.
Your team basically has to decide how a user is going to use this program, whatever JavaScript program or backend, whatever, doesn't matter. This code, how it's going to be used. And that's why I think we're kind of stuck in this local minima of, okay, that's the best we can do with this kind of interfaces.
Okay.
But I think that's we cannot progress much there, I feel.
Interesting.
For example, now we're with a new kind of interface, not only voice, but imagine two graphical programs. How do two graphical programs interact at the moment? Let's just abandon websites and say just have two programs Photoshop and Slack. Okay, so you have Photoshop and Slack. How do they interact? Well, basically through the clipboard, screenshots, and right. Yeah. There is no. I mean, imagine how do you do that if we had something like graphical Unix pipe. Mm-hmm. We just don't have that.
No.
We impose structure absolutely everywhere, and that's actually what Unix pipe works, because there's no structure. We just don't impose, the program doesn't impose structure on the user or on the other program. It's just text.
Yeah.
So now I think with language models and vision models, etc., artificial models, we can do structureless communication between programs, between graphical programs. So that's why I think the whole forms and events and blah blah blah, I think it's okay, but I think that's as good as it's gonna be. It's not, I
mean, they do serve a purpose which is very isolated within those applications. Like the example of Slack versus Photoshop, I don't think there is much need because they are owned by different organizations. So there's no reason to coalesce.
No, but for you, as a user.
For me, yeah.
Yeah, but that's what I mean. So now in those two organizations, a team has to be formed. Yeah. And they have to create an interface structured. And then I have to say, okay, how are we going to communicate?
Yeah.
And you as the user, somebody has to decide for you what the possibilities are of this communication. While I think we have to go to a place where you actually have infinite possibilities of how to use your programs. It could be a game that you wanted to interact somehow with a bot that you have made.
Yeah.
Now that's not, either you have to just take the screen and hijack the keyboard, but we should come up with interfaces so that the programs can do that themselves.
Yeah. Right now, I didn't even think of that, because everything is it works in isolation. It works within the application. It doesn't cross the boundaries to other either physical things or other software things. and that's it. But it's also because everything is driven at the end by money, right? There's no reason for adding that to a user experience for things to merge and interact and synergize if there's no financial incentive at the end of the day.
Yeah, it's true. Well, but the things, even like open source things, like volunteer things.
Yeah.
Just think about how hard it is for your IDE to interact with things around it. Like you have to get like plugins, and somebody has to write a plugin. The other thing has to expose some API to use it, and that's like a shame. I think that's like if you use some. Do you know Acme, the editor Acme?
No.
It's a very old. It's like a mouse. It's this yellow. I don't know. Rob Pike uses it, and but you basically have your text editor, and then you have commands inside of it that you can just execute with the mouse. Basically, you can select a bunch of text, and you can pipe that to, I don't know, a grep or something, and can open a new window, etc. But the idea is, from the editor, you interface with everything around it.
Okay.
And that Unix pipes actually would make that possible.
Yeah.
But if you use Visual Code or something, you just can't. Even between between the text, the code, and the terminal below it, it's not trivial to interface between those two things. And that's why I think it's the same if you on the web or everywhere. If you have like if you want to search, imagine you want to search for a flight, but at the same time you want to actually see how close are hotels to this. If some hotel website doesn't offer you both of those things on the same page, you can't do it.
No.
You have to like select and that, you see what I mean? That's like, it's just, that's as good as it's going to get. The whole frameworks and etc. It's not going to solve this particular problem.
Yeah, interesting. Like for me, because I grew up with, I think, technology at a stage where there were already abstraction layers. My first production experience was on Google Cloud, for example. I've never done software on bare metal. I've been responsible because I started my career in operations. But when I was moving to software engineering, that's when I started with those layers of abstraction already. With front end, I started with React. And I was like, okay, this is really cool. And these are how the components fit together. But then later on, I got experience where it was just Go HTML templates and vanilla JavaScript. And I'm like, man, this is so much more performant. It works like a charm. We had a lot of A/B testing and it executed really well. Like, I don't know which abstraction layers are harmful or helpful, because I do feel like some stuff makes me more productive, but it's also because I don't know what it would mean to kind of run without.
Ideally, I wish the browser is just a virtual machine that can run my program, and not this weird rendering engine plus all these other things. So first of all, React was much better than what we had before it, right? Which like it seems, at least the way you can have many people working on the same project. It was just much harder before the Angular React age, I think. We had like Backbone and what did we have? Meteor, I forgot the other stuff at the time. And so in that sense, it was absolutely progress to have this abstraction of, well, going back to PHP, of code and data in the same place, and you can manipulate both reactively. Right? A big problem was that because it was so unopinionated, there were like 1,000 ways to do state. And that was the community kind of like forked a lot, and then that led to, okay, we have to kind of like try to find the common way, and then just things went in bad place, I think. But it started like, first of all, the idea was, well, the DOM is, we cannot re-render the DOM so much, so it's slow, so we have to render only the thing that has to be rendered. If you look, and that was the case before, but now the DOM is just ridiculously fast, and also a lot of the you can do a lot with the browser's own just possibilities. Right? You don't need a lot of the things. We still have not solved. So if you talk about abstractions in, okay, can I write faster code or better code. I think you can do better with the browser, but can you do something? Can you have a lot of people working on a project that's still not solved?
Okay.
The mirage of like, let's reuse a component, which is just impossible. Like you have to, people start parameterizing it. Or
people try. Yeah, absolutely.
Have you seen it work? Like actually reuse a button?
Yeah, to a certain degree. Yeah.
I've never seen it, man.
No? Well, no, what is then? Why doesn't it work?
First of all, because of A/B testing.
Okay.
It's really because somebody comes, I want to make this red, and they're like, okay, do I fork the button or do I parameterize the button?
Yeah, parameterize. That's how it goes.
Yeah, and then they keep like, I want it to be a little bit in some context. I want to be like this. In other context, I want to be like that. And because they can't change the parent component, they have to, and so they keep. It just keeps piling, and then in the end, it becomes this like monster.
But is it because I would say it's then because the design system, right? That's when I would push back and be like, this is ridiculous.
Yeah.
We don't need a million variants.
Of course.
Yeah.
But A/B testing does not allow you to do that because somebody says, but what if it brings more money?
Okay.
So you cannot push back on it. You have to have a super strong design leader,
yeah.
which has to be able to say no to money. Right?
And then like even with a few variants, at the end one wins, right? So then we use that one, or do we want to continuously keep?
Because you don't know if it's worth for the other ones. Because
really?
We have it in context. Like let me just look at. Let's say I have this X. Let's say I have this X on the. In Xebia's logo,
yeah,
and then in some context you want it to be red, right? That doesn't mean in the other in all contexts it has to be red.
Really? Okay.
Yeah,
that makes sense.
So that becomes like it's such a difficult thing to actually say no to this experimentation, and rightfully so, right? Because you don't know actually.
But if that's the experimentation to such a degree where you do it, let's say either in a phrase or in buttons, then how do experiments not clash with each other?
But they do. Well, that's why I have like call it like white on white. So some team has the logo to be white on a black background. Somebody else has it black on white background, and then of course there's like some interaction between it's always like white on white or black on black, and you do. So you have statistics to actually see this happening.
Okay.
Yeah.
But even when, like, on a button level, you can A/B test, but also the components around it, like things influence each other, right?
Absolutely. No. That's It's fine. People do it. I think that's like a waste of time. Not a waste of time, obviously, but I think people's time can be better spent on making better Excel.
Yeah, fair. I mean, if that's the level of degree, then I agree that your list of variables when it comes to a single component is going to make that super specific, and it's not easy to plug and play in a different context.
That's it. But the thing is, when you have like a list, you have the same problem. Like how do you start like? Well, sometimes I want the head of the list to be a little bit different, and then it doesn't fit. Then on mobile, I have to be like this. So it just keeps especially about the things that you use a lot. I think it's really hard to actually make them reusable. And the other ones you don't use at all. Like there's no point of being reusable because, so it's like the only reusability matters for things that are actually going to be used for like weird things that you only use once. It doesn't matter.
But I always have this discussion with people that, and especially back then when I did more front end, it's like we need to make this more reusable, right? And I'm of the mantra of let's just copy and see if we have another copy, and then we see what's the common.
Well, that's the rule of K. You have to have K. Like you have to do something when K reaches some number.
Yeah.
For me, it's like usually 3.
Yeah, same.
And that's okay. I think that's okay. Let's do it. Let's see what it happens when it's 3, and then we can decide to. I think that's the right approach.
Yeah.
This like pretending to see the future. First of all, you don't even know what you're writing. You don't even know if people are going to use it. You don't even know what it is. As you start with something and even the whole team, they have to like clash, and somebody have ideas, and somebody will like, they just like not like it, or somebody will like something else, and then you talk to users, and then, well, that's not actually what you wanted or what they want.
Yeah.
So you don't actually know. Why would you try to make reusable something that you're just going to delete? It just makes no sense.
I agree. For me, then, what makes someone really good in a team is this flexibility and kind of more practical mindset. But I do agree that the more you love like what you're doing, the more also your output matters to you. At least That's what I've seen some people do. So then what they want to create, they do want elegance, for example, which I think is very subjective.
Yeah.
And they do want reusability, even though it might not matter because it might not be used. And that's a hard conversation for me.
Yeah. I mean, it is hard because it's just, you have to challenge their values.
Yeah.
So it's like telling a vegan person that meat is good.
Exactly. That's how it feels, to be honest.
I know.
Yeah.
It's the same with when you're a parent, but it's the same if you challenge somebody else's parenting methods. It's just, you get into a territory of, it's really hard. So a lot of people, by the way, use experimentation to just tiebreaker. It's like, let's just do it. Let's just test it and we'll see. Right.
That's what I try. That's one of my things I have in my pocket.
Yeah. But it's also a way out. I don't. I think it's. I mean, I've been in this situation a lot of times, and sometimes you have to. It depends on your personality, right? You're like, let's just see. It's okay. That's what they want to do. That's what they want to do.
Yeah.
And you have to. If you can't convince them, I don't like the commit, like what is it, agree to disagree
and commit
thing. Yeah, disagree and commit thing. But in the end, you're just like a person in the team as well. And it's much better for somebody to do something that they enjoy than for them to do something that they don't enjoy.
Yeah.
In a sense, sometimes you also have to say, then you just have a time constraint. Well, what can you do actually in 2 hours, whatever the number is? And that actually forces them into... Or
like solution mode.
Solution mode. Or you can also say, like, look, I just promise you, let's write it like this. And then we'll absolutely put time in the calendar in the future to fix it.
And then you defer.
Yeah. The thing is, there is no good solution to that because it's my opinion. None of us knows the future.
Yeah.
Right? And none of us knows it's even if this actually is going to be used. So you can actually agree on if this is used more than X, or like the actual next time we use it, we're just gonna abstract it. But in the same time, you also have to push back on unnecessary abstraction.
Exactly.
So you can't. It's so natural to abstract, but the reality is like with the electricity of the if, right? That you can't. You just can't. Everything leaks. Every single thing leaks a lot, and people have this bias to elegance or to, but the truth is that even even things like let me see what you might think it doesn't leak. What IP?
Okay.
The internet protocol itself leaks, and TCP particularly, the way it controls its bandwidth, it leaks so much into the way you make WebSockets.
Okay.
You might be, you have WebSockets on top of this, but they are even it leaks through the libraries that you use to manage the WebSockets, because there are things like half open TCP connections. So you think it's open, the other side doesn't think it's open. There are things like which is just ridiculous to debug. So that's why you have like heartbeats, and then you have what about duplex and etc. So can you send the thing but doesn't come back, So even you try to run away from it, but you have to. It
you
leaks.
have to accommodate.
Yeah, it just leaks. What about when you have like multiple? Because on mobile we have like multiple networks. Can you connect to multiple paths, etc., etc. So you have to push back. Like at some point you have to be like, that's not the way. You can't pretend. There's like just a reality check. You can't pretend that that's not going to happen. So
when it comes to then, let's say, forming a team, because I feel like these conversations are helping a group of individuals become a team. But do you take into account this, for example, when you're hiring people, that you have kind of a similar mindset of how do we execute and what do we have like opinions on that differ, which matter? Yeah. Or where do we align?
Sorry. I think the most important thing for me when for a team is to have like a shared sense of what actually technology is in our purpose, like in our team. There are people that are like language, how to call that, zealots. I don't know how they just like they want to go to a company because it's using the language that they like.
Yeah.
So I just really try to stay away from them.
Okay.
Purely because what you want is to have people that are interested in the problem that you have. And technology is just the thing. It's just code. It doesn't really matter at all.
Yeah.
So the abstraction thing as well is a similar problem. Like to be able to understand when to do it and when not to do it.
Mm-hmm.
So I definitely think that it's important to when people are too far away. It's like the vegan meat thing.
Yeah.
Sometimes it's not going to be solved, especially when people are like super convinced of something.
Mm-hmm.
So that's also important to just when you talk to somebody on the interview is to understand, can they change your mind and can you change their mind?
Yeah.
Right? So if they go in a conversation with as if you're talking to a wall, like it's immovable. So you're just either wasting time.
It's pointless.
It's just there's no point. Right?
Yeah.
So if you have a person that can change their mind, and if you have a person that is interested in the problem, I think it's okay.
Mm-hmm.
But because they can be, it's okay sometimes to argue because of course you're not always right.
Yeah. So it's healthy.
Yeah. So it's even better. You want to hire somebody that actually helps you, right? To teaches you and ideally.
This language that kind of stuck with me because I told you I'm very fond of Go as a programming language. I also love problem solving. So then the ideal match for me would be both, right? Interesting problems and with a language that I feel most productive with, because then I can solve those problems faster. I have a hard time starting things, and then this hump of, let's say, learning a new language and getting to a level where I feel as productive, that for me is like, doesn't feel nice. It doesn't feel like I want to do that, even though it might be beneficial for me as an engineer.
I see what you mean. First of all, now it's very different because you just have a Claude and GPT, and then it's just like learning a new anything is just so nice.
But it feels like it might accelerate my learning, but I still have this inkling of I don't know what I don't know, and what if it's wrong?
Yeah. I know what you mean. But depends on depends on languages.
Yeah.
Like for example, if you learn a new, if you have never done Lisp or Haskell, I think it's great to do. Just for like, it's almost like having a subject, like, some languages have like cow eats grass, but their languages eat cow grass and cow grass eat, you know? Like if you learn all the languages that are like, and they're about 40% of the language, cow eats grass, I don't think it helps you a lot in any. But if you learn the other ways of thinking, I think it's very, of course, it's very hard. It's much harder, right? Like learning Japanese or Arabic or, But I think it's almost like, or music, it's like the same thing. So you shouldn't try to stay away from it purely for growth. Because it would teach you to think differently about anything. So that is not the same as, I have to learn, I know Java, I'm going to learn C# now. Whatever, it's the same. You might be very productive in Java, you know nothing about C#, it's fine. You might be very productive in Go. You'll be just as productive in almost everything. You're just going to learn, it's going to take like a month and maybe half a month.
Maybe I overestimate how much time it's going to take.
No, a for loop is a for loop. It's okay.
Yeah.
I don't. The thing is, you have to learn the idiosyncratic things that they do, like where they abstract, where they don't abstract.
Exactly.
That is kind of weird, and that also it's not actually a language thing; it's a company thing. Because a company has certain culture. Like for example, booking. Booking was a Perl shop when I joined.
Yeah.
And Perl is like a multi-paradigm language. You can write whatever you want, in whatever way you want. So when somebody comes with like a Java person comes, they're just going to write Java Perl. When a C person comes, they're just going to write C Perl. It's like this.
That's a problem.
It is.
Yeah.
But it's also part of the company's culture to say what do we accept?
Yeah, what do you
think is the way to do it?
Yeah.
So it has nothing to do with Perl. So that's
how you use it.
Yeah, it's how the company uses it, and so it's the same when you go to a company and you can be doing Go in a certain way. Or Go is a bad example because it's particularly narrow. That's the whole point.
That's why I like it.
That's why they made it like that. Condescending, but But yeah, so that's the point. And it's very, very effective. Actually, my current company was an elixir shop before when I joined, and I was like, we can't do that.
No?
We can't, no. It's too... Well, having weird business rules in functional language is just such a pain.
Yeah, it's messy.
You just pretend that you can do it's just everything is hard. Everything is hard. And then we're just moving to Go. So we just, like I said, we just write everything in Go. It took us 2 months or 1 month or something. And all of a sudden, because previously we had this hard split between front-end and back-end developers. Because it was almost like a gate. Only certain people could write Elixir.
Yeah.
Wow, literally nobody was writing Go before. Nobody has done any Go. And I said we're just going to Go. And in a week, everybody's just writing Go.
Isn't that great?
Yeah, that's what I mean.
Yeah.
That's the point of it. It's great. And then we just rewrote everything. Now all the developers became full stack developers.
Oh, okay.
And it was just done.
So they also became comfortable enough to do the back end.
Yeah. And then the other way, it was just we moved at the same time to React Native and to Go.
Okay.
So yeah, I think that it's a great language.
Yeah.
In this, I don't think you can do that with other languages.
No,
I don't think it's possible to in a week to get people productive in it.
Exactly. Yeah. Do you think full stack nowadays, let's say Go is a backend language, then I can see it. But with other languages, because of let's say how wide you can go, and because of how open and flexible this toolbox is, and you have to get used to the conventions of the organization, it becomes harder and harder, right? Cognitively. And then you also have layers of abstraction that can either make things simpler, some cloud stuff, but also more complex, some stuff that runs on the cloud. Then it becomes harder. And full stack is now also evolving, I think, with the role of AI. So it's becoming a lot.
I think, look, especially with let's it's true that what does it mean to be full stack means you have to know so many things, just so many things. In the end, I think most of them are for loops kind of thing. Yeah. But it's becoming impossible, basically, to do that. To be on top of all these things that are just constantly changing.
It's difficult.
I still think that the most you have to start just dropping things. You have to be what is actually, because now let's say with let's say a new framework, you go to a new company and then they use whatever Vue instead of React, and the real thing is do you actually know V8 or not?
Yeah.
Do you know JavaScript or not? Do you know what is fast and what is slow? Do you know the event loop, etc.? It's not. And then after that, using language models, you can really transfer between all these things, and you can even paste a bunch. What is idiomat? You can ask it, and it's fine.
Yeah.
For this particular stuff, it's actually okay because it's just the average of everything is a scene, right? So I think you should, as a full stack developer, I think you should really stop looking at just frameworks, and you should really look at technologies.
Okay.
And really, I think actually AI is going to consume, for me particularly, consume maybe 50% of my time now.
Oh, really?
Yeah. Just playing with it and making things, and not prompting, just making things.
Like just products? Or what do you mean?
Just make neural network that plays Go. Just a small one. Whatever it does. Just try... just play with it, you know? Because I think... So, if you think of AI as just this is a tool that whatever. But I think of it more as just a new kind of programming computer. So it's to learn how to program these machines. That's what the transformer is. It's a differentiable computer, self-programmable differentiable computer. So how you have to learn a new kind of languages to interact with it. Yeah. I'm not talking about PyTorch. I'm talking about, there are compilers that can compile weights for the transformer that can do certain things. So this is what I mean to actually program the transformer is just a new kind of thing. And if you want, it's a new completely new language, a new paradigm, the first new paradigm. So if you want to be a full stack developer, I think now is to learn how to make these machines and how to program these machines. Imagine there's like a new kind of computer that you just have to program that just didn't exist. It's and the old stuff now you can use language to transfer because all the other stuff is basically the same. So and you can use language models to just help you just move between all those things.
Yeah.
But the basically the limb that you're missing now is AI.
Interesting.
So the rest I think is like kind of like static and it's like completely running in circles. So I don't worry about that. So I think the modern, at least the one I want to be, is as a full stack developer, is you have to be very, very comfortable with making and solving actual problems with I don't know state space models or transformers or just the modern, which are the modern technologies.
Interesting. How are they gonna? So I'm always wondering because this new technology came out. I think it was late last year, and now we're here almost a full year later. A lot of things have happened, and a lot of things have gotten better. Right? I talk to people, and they're like, "Well, I saw much hallucination. It was really bad at programming, so on and so forth." I'm like, "When was the last time you tried it?" And they tell me many months ago. No. I'm like, you should try again because things evolve and they evolve very quickly.
Yeah.
I've also told this many times on the podcast, but I always kind of idolize people that start their own company and do something with it. And for me, I think this technology is going to be really disruptive, right? Because people say always, oh, this is disruptive and so on and so forth. I feel like this is going to stick more so than blockchain, Web5 and other things that people are working on and that were more of a hype, let's say a few years ago. I feel like this one will stick.
There is hype around it.
There is definitely hype around it. No. And people are also getting sick of it from a developer and usage perspective. But I do see value in some aspects. I just don't know where it will stick. I feel like education is a big component of it. Yet there's dangers because of hallucination and because of like knowledge gaps.
Yeah.
But I really wonder where it's going to be applied because that's where I want to be as well, I feel like.
Yeah. Yeah, I think now where I am, I'm purely interested in it as a child.
Yeah.
So I am not even thinking about where, because it's just so, I mean, when you're on the steep part of the exponent, it seems like there's just no tomorrow because tomorrow is yesterday. So you're like, we're in this stage where tomorrow is yesterday and it's like everything's just crazy and anxiety and etc. So just looking at it from purely like childish point of view, like just like playing with it and etc., trying to understand it, because I just don't think we understand it.
Yeah.
As in, there's like I don't know who said this example, but they gave this example of oil. So when in the 1900s, people used to like light their candles, not candles, but their like night lights, etc., with whale fat.
Yeah.
And then when they started bringing oil, they started just burning the oil. And it's replaced the whaling industry in like 2 years or something, just disappeared. But people were basically just burning it. So they were just burning the oil, and that's until we actually made the internal combustion engine. The only thing we did with oil was burn it.
Okay.
So I think now we're just burning tokens, and we're just burning it. We still have not made the internal combustion engine with this technology. So that's why when you say I want to be where it is, I don't like this thing is still burning. So it's really hard to say what actually it's going to be.
Yeah.
And I think the best thing you can do is to understand it. So in the sense of, in the metaphor with the oil, it will be to understand, just play with it and see what you can do with it. So you can maybe find the internal combustion engine, or at least you understand its properties, so that whatever happens after, you can use it.
Yeah. I feel like everyone is trying to find the internal combustion engine, like continuously, basically. And it's like an arms race.
I mean, reasoning is one way to say, like, let's not burn the tokens. But I just don't know. Because it could be like this new kind of interfaces. It could be like this program communication thing. It could be even things like one network just synthesizing data for another network so they can interoperate, or like robotics, etc. Right? So we don't know, but I don't think we'll know in the next like 2 years or so.
Oh, okay.
I think, well, I'm worried is that it's gonna get like really bad with. I mean, we were just talking that all these investments in it, we have to pay for it.
Oh yeah,
and like this, when the feed becomes like heroin level, you can't just stop. You can't stop. That is when I think it's a big problem. So we have to be really cautious of that happening.
Yeah.
And that's kind of like orthogonal to, because people will not try to find, okay, let's use that for something
good.
Beneficial for society.
Yeah.
The possibilities of it are like immense, right? But as Jung says, the stronger the light, the darker the shadow. So let's see when you have like a subtle, well, I mean, there's already but people have it as romantic partners, and there's like some people commit suicide because it's just really, really, there's like the way we use it now is not even that we're in the burning phase.
Yeah.
So you have to really position yourself in to separate the technology from the way we use it, as almost all the uses are like super shallow and kind of, I would say, mean, like kind of exploitative and etc. And you have to, that's why I think if you spend time on understanding and playing with it like a child, I think you are much more likely to go to the internal combustion engine than just jumping on the, of course you can make it to have the perfect recommendation that is going to like make you not leave your phone, or how much should you delay the Snapchat notification so that people can that have just left the phone, they'll pick it up again and things like that.
Yeah, that's more the harmful side.
Yeah.
I feel like we are investing both with our time from a usage perspective as well as from just a knowledge perspective and trying to understand. But the more and more I think of it as a broader thing, like the planet is also suffering because compute is going to go up, right? We're burning oil is the same as burning oil elsewhere for running these things, basically.
Yeah, that's true. Yeah.
And then it's going to be harmful for the planet. I hope it also shifts around and like brings good to society. But as long as there's no incentive from a financial perspective, there might not be, which is destructive at the end.
I mean, all the big tech companies have dropped their climate goals.
Oh yeah.
So that it like immediately,
instantly. Like they had targets, and then you saw ChatGPT came out, and compute went through the roof.
Yeah. And they actually officially have done Satya Nadella and the Google guy, forgot his name. He also, like, everybody just like, no, we're just not doing that.
Yeah,
that's it.
It's a race now.
yeah. Like we have to. That's it.
Exactly.
That there is like definitely like a group of Silicon Valley people that they are building like the machine god. There is no way. It's like a religious thing. It's not even, it's a spiritual thing, and they're just going that way, and they think it's going to save us. It's going to save us from ourselves. It's going to solve energy. It's going to solve aging. It's going to solve death, which is like, that's, and they're just going. They're just like completely just, they don't, there is no,
that's their combustion engine.
Because because they also think if you don't, the other thing also doesn't work. Like the climate goals we had for like, I don't know anything about, but I mean, we were not on target.
No. We have to do a lot, basically. Yeah, it needs to be fully regulated. You cannot do business if you don't have ambitious goals. That's the only way it would work.
But even with the trajectory we're in, it was just not going to work out anyway to 2050. So they're like, if it's not going to work anyway, let's just go all in on this thing. And let's just...
Big risk though, but big reward.
Yes. So that's, I think, the bet. I don't know enough about the subject to talk about it. Besides... I hope it works out.
I'm in the same camp. Like, I feel like I'm not a subject matter expert. Like, the tool that we're building at the customer that I work at now is completely in the sustainability domain. Like, seeing what companies have their targets, if they're ambitious, and how are they meeting them, basically. Giving overview of that, to also steer. So that's why I'm a bit more like invested in this topic. And it goes hand in hand with all the technology boom that we have, where compute went through the roof. Like, that's where I see it do harm for the planet. And there's only hope. There's only, but I do want to be kind of in that direction, because I feel like it is disruptive technology. I don't think it comes often that we have something like that.
I think that's the first time since the Industrial Revolution, maybe.
Since Industrial Revolution.
Yeah, I think even language level, you know, like the best technology we have is language. That's the first technology we have and the best technology we have. The reason why language is an important technology is because, well, reality is projected from our brains. It's like simulated, right? So the only way two people can communicate is symbolically, because we perceive completely different reality. And even in symbols, like that's why language is like such a important technology for our species. And I think this is now like almost like language level technology.
Yeah.
That, especially if it starts self-accelerating, which I don't know if that's going to happen. Well, there's already some, but it's at least in the last 100 years computing-wise, I think it's the first paradigm change that we see.
Yeah, exactly. I've really enjoyed this conversation, Borislav. This was a lot of fun. I'm going to re-listen to this and really zone in on the things you mentioned, because I feel like there's a lot of takeaways there. Before we round off, is there anything you still want to share?
I just, for anybody that is like starting right now, I don't think they should read Reddit. just do the thing that you want to do, and again, just try to find joy in like the little things of programming.
Yeah, I really like that experimentation thing. I know there is joy in that, but I also know day in, day out, I don't do it often enough. Yeah.
So it's just day to day, and you just like I have a meeting at 1, and then I have to do this thing, and I have an interview at like 6, and whatever. But if it's 10 lines of code, just enjoy the 10 lines of code. You know?
That's awesome. Yeah. We're gonna round it off there. Thank you so much for listening. If you liked the episode, leave a like. Let us know in the comments what you thought of the episode, and we'll see you on the next one.